This is an example involving an impact simulation with a square tube. I've just used some example in a journal. It's a good journal written by Tarla Chan, ETAL. Hopefully I have spelled it correctly. Anyway, we create a part first. We name this part as square tube. We use cell section and its extrusion approximate size is 200. So we click continue. We use rectangle tool. It's minus 37.5 comma minus 37.5. I hit enter. It's 37.5 comma 37.5. I hit enter. I click the middle button. It's done. I will use an extrusion depth of 350 mm. We've got one part ready. Now I will create another part. It is upper plate or punch, you like punch. It's again 3D. This time it is discrete rigid. It's shell. This time it is planar. Approximate size is 200. Again, it's okay to have that size. And I'll click continue. Again, I will use rectangle tool. I will use minus 45 comma minus 45. I'll hit enter. 45 comma 45. I hit enter. I click the middle mouse button. It's done. What I do is I will copy this punch and create another part. It's identical to the punch. This time I will use this, rename this as a base. There you go. I will switch to current part. I will switch the current part to punch, and I will create a reference point. It's at 0, 0, 0, and let me see this. Yes, it's over here. I will rename this as punch RP. I will create a set and I will rename this set underscore RP. That's the name I want to give this, and I will select that punch. It's done. Now I will use a similar procedure on base. I will create a reference point, same place again, 0, 0, 0. Rename this. Base RP. Create set RP. I will select that. It's done. Now, having completed the construction of the parts, now I will create a material. This time I will use aluminium. So it's aluminium with material density 2.7 into 10 power minus 9 ton per meter cube, 10 per mm cube, sorry. It's Young's modulus. I said the Young's modulus is a 68.9 e power 3. Poisson's ratio is a 0.3. I now give plastic data. if you got an Excel, everything typed in Excel, it's a lot easier. Anyway, it's 80 0 115 0.024 130 0.04 150 0.079 158 0.09 167 0.124 171 0.14 173 0.174. I'll make this as a rate dependent with hardening power law would do multiplier 1 and exponent 0.23. Data being taken from a literature. Click OK. I will pause the video and have a sip of coffee now. Now we create a section for this tube. I will call it as sec tube. It's obviously shell section with homogeneous thickness 2 mil. I will assign this section now. I will prepare mesh. I'll make it quad dominated and structured, and I will seed edges. This is edge, another edge, 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 done. Number prefer to give something like 100. Apply, done, and I will seed edges 1 2 3 4 5 6 7 8 done. Mesh element type I will select as explicit as 4 R type elements, default ones. Likewise I will mesh punch R3D4 type. I will use 4 elements per base. Mesh element type again R3D4 type. Seed edges, select that 4, done. Mesh part. Now I will assemble them. First I would instance the square tube. It is rather strange. I will cancel and double check it once. Have I actually meshed parts? Yes, it's been meshed. Square tube hasn't been meshed yet. Yes, now it's meshed. Now I will instance the part. Create. Yeah. I selected square tube because it's been meshed already in the part phase. Software doesn't give an option for say independent mesh. So I'll click apply. Now I will instance punch and I will click OK. I will move this punch over to here, which is about a distance of, I believe, around 350 mm. So what I do is instance translate. I will select the instance punch. 000 is its existing position and its final position is 350 mm away, and I will hit enter. It's done. Now I will instance the base. I will create a step. It's explicit, dynamic explicit. I will run it for a very short period of time, 0.02, because I want it to be very quick. Mask scaling on this particular instance is not required because we are running it for a very short period of time. But if we want, we can do it. I will leave the mask scaling for this. Leave it mask scaling for this exercise, and I'll click OK. Having done this, we now create interaction properties. Create an interaction property. I will leave the default name as it is. Mechanical tangential behavior penalty. Fraction coefficient of 0.2 or 0.153. You can select anything. Having completed, now I will create interactions. Create general interaction properties. Click OK. Now I will create a surface. Surface on the base, on the geometry. I'll select this. It's towards the brown side. Now I have selected. Now I'll create a surface on the edges. I'll make it transparent. Create. surf on a tube towards base. So I'll use B as a kind of indication. I'll select this edge. I will select this edge. I will slightly rotate this. Now I will create a constraint. I will tie this. It's been created now. Now I'll create a boundary condition. Boundary condition 1 is to it is for base RP reference point. I will select that. I will restrict all its degrees of freedom. Boundary condition 2 is equal for punch RP displacement, its initial punch RP other than its U3 Z direction degrees of freedom, rest were restrained. What I will do now is I will create an amplitude tabular type. Zero is equal to 0, 0.001. I will use it as actually not required, but I will insert another row after, which is 0.02 final time, and I will use 1. And I will click OK. Go to boundary conditions manager, punch, edit. Here I will use 1000 mm. I'll click OK and I will dismiss. Hopefully I have done everything. I'll call this test. Continue. Click OK. I will submit this.